Welcome back. One thing I forgot to add, and so I had to come back and add it in, was let's talk about solutions. So if you have matrix A, the following statements are equivalent. AXB has a solution. If AXB has a solution for every B, then that means that each B is a linear combination of the columns of A, or the columns of A span all of Rm, which also means that A has a pivot position in every row. That means a leading coefficient in every single row. And that is the key thing that we're going to use. Now let's talk about properties of some matrix vector products. So if A is a matrix and U and V are vectors and C is a scalar, then A times the sum of U plus V, I can just distribute to A. Now, a key thing is to note that the A is on the left-hand side, just as it is over here. That is critical. If A is times the scalar, we might as well just pull the scalar out and do A times the vector U. And that is a key thing. Now, here's an extra couple of pieces of information and warning that I do want to hit on. We have a key matrix that we love called the identity matrix. It is a square matrix with ones on every diagonal entry and zeros everywhere else. It's kind of like multiplying a vector by 1. Also, the order, and I mentioned this just previously, is important in matrix multiplication. And matrix and matrix vector. So in linear algebra, order of multiplication is important. Addition, not so much. Multiplication, yes. Also, one final note, you cannot divide by a matrix. We will give an alternative idea to this much later, but you cannot divide. All right, so let's do some examples to kind of round this up. We want to simply take this matrix equation and turn it into a vector equation. I want you to think about it for a second and try it. How would you write that as a vector equation? Well, the simplest is to write it as x1 times column 1, x2 times column 2, and x3 times column 3 is equal to my B vector. All right, that was easy. Now, let's have U and A. If I say, is U in the plane of R3 spanned by the columns of A? Okay, that sounds all fancy. What that means, as a reminder, is that is this augmented matrix where notice I have matrix A and I have U. Does this augmented matrix have a solution? So go ahead and pause the video and solve that augmented matrix. Hint, row reduction. All right, so if you did that, you can do row 2 plus 2 times row 1, and then I can do row 3 plus row 1. Looking at this, I can further say, okay, I can scale row 2 by dividing by 1/9, and then I can take row 3. And notice I have a row of zeros on the bottom, so that's essentially I could throw away row. I can ignore it. Now, if I would love to solve this, but the big thing is I have a leading coefficient in every one of these rows. I have 2 leading coefficients and 2 variables. And so actually that means that I do have a solution here. So we don't have to go any further steps than that. Because my row echelon form, which this is because that's a -1, and because I didn't get rid of the 4, I don't have to find the solution. I just have to know that there is a solution. Hopefully that makes sense. All right. Last, A is this giant matrix. For any B, in R4, does this have a solution? Well, to understand that, what we're really asking is, can I row reduce this? And when I row reduce it, how many pivots or how many leading coefficients are in the row echelon form? Well, if we take this, we can row reduce it, swapping rows 1 and 2. Then we take that and we say, okay, let's do row 2 minus row 1. That just killed a huge chunk of stuff. We're really happy. And then I do row 4 minus row 1. I personally am going to swap out row 2 and row 4. So I have a nice, and then I'm looking at my pivots and I have row 1 and row 4 and row 3. I add them together and you get this. Notice I have how many pivots. Every row 1 has a pivot, row 2 has a pivot, row 3 has a pivot, and row 4 has a pivot. What that means is every row has a pivot. So this has a solution for every B. It may not be unique, but it has a solution. And that is the critical part that we will rely on. I hope that helps. Please let me know what questions you have. Good luck.